Now that we have learned how to operationalize a concept, we need to assign numbers or other symbols to it in some manner. Numbers allow us to perform statistical analysis on the resulting data and in deductive research to test the hypothesis that we have developed. We will first discuss 4 different types of scales, that is nominal, ordinal, interval and ratio scales in part 1, and point out that the statistical analysis we can perform later on the next research process. We will also discuss 2 main categories of attitudinal scales, not to be confused with the 4 different types of scale discussed first in this chapter. The rating scale we will cover in part 2, and a ranking scale in part 3. And another part will be reliability and validity. After completing this chapter, you should be able to understand the levels of measurement, understand rating scales, understand ranking scales, and identify goodness of measure. To be able to assign numbers to attributes of objects, we need a scale. A scale is a tool or mechanism by which individuals are distinguished as to how they differ from one another on the variables of interest to our study. A nominal scale is one that allows the researcher to assign subjects to certain categories or groups. For example, with respect to the variable of gender, respondents can be grouped into 2 categories, male and female. The nominal scale categorizes individuals or objects into mutually exclusive and collectively exhaustive groups. An ordinal scale not only categorizes the variables in such a way as to denote differences among the various categories, it also rank orders the categories in some meaningful way, with any variable for which the categories are to be ordered according to some preference. The ordinal scale would be used. In an interval scale or equal interval scale, numerically equal distance on the scale represent equal values in the characteristic being measured. Whereas the nominal scale allows us only to qualitatively distinguish groups by categorizing them into mutually exclusive and collectively exhaustive sets, and the ordinal scale to rank order the preferences, the interval scale allows us to compare differences between objects. The ratio scale overcomes the disadvantage of the arbitrary origin point of the interval scale, in that it has an absolute 0 point, which is a meaningful measurement point. The ratio scale not only measures the magnitude of the differences between points on the scale, but also taps the proportions in the differences. It is the most powerful of the 4 scales because it has a unique 0 origin and subsumes all the properties of the other 3 scales. The weighing balance is a good example of a ratio scale. It has an absolute 0 origin calibrated on it, which allows us to calculate the ratio of the weights of 2 individuals. These are the examples of some of the variables that belongs to the nominal category: gender, ethnic group, and marital status. Other examples you can find in the form. Different types of houses also belongs to nominal category. The important characteristic of a nominal category will be non-number or qualitative, and it is categorical. We can see now that the ordinal scale provides more information than the nominal scale. The ordinal scale goes beyond differentiating the categories to provide information on how respondents distinguish them by rank ordering them. For example, educational qualification. We know that PhD or professional qualification is higher level compared to the other degrees. Even though differences in the ranking of objects, persons, or events investigated are clearly shown, we do not know their magnitude. This deficiency is overcome by interval scaling, which will be discussed next. The ordinal scale has the following characteristic. It is categorical, it has sequence or rank, and the statistical measures for ordinal is median. In an interval scale, the difference between any two values on the scale is identical to the difference between any other two neighboring values of the scale. The clinical thermometer is a good example of an interval scale instrument. The interval scale taps the differences, the order, and the equality of the magnitude of the differences in the variable. As such, it is a more powerful scale than the nominal and ordinal scales. When responses to various items that measure a variable on any form of Likert scale are summed across the items, an interval scale is obtained as illustrated below. This is the perceived value. We measure the loyalty. This study used the subjective measure to find relationship among personality, motivasi, and prestasi kerja using the interval scale. The interval scale has the following characteristics. It is in terms of numbers, it has no absolute zero, and the measure of central tendency involved is the arithmetic mean, and the measure of dispersion are the range, standard deviation, and variance. The ratio scale overcomes the disadvantage of the arbitrary origin point of the interval scales in that it has an absolute zero point, which is a meaningful measurement point. Some variables can be presented in several formats to achieve good response in specific situations, such as age. Age can be represented using different formats such as the following. It can be in format A as a ratio scale, where the respondent need to fill in the number of years, or it can be in format B as an interval scale. The researcher provides the interval for the respondents to choose, or in format C as an ordinal scale. It can be divided into two young adults or older adults. Then the respondent need to fill in which category they falls in. The ratio scale has the following characteristics. Must be ratio data. It's in terms of numbers. It have absolute zero, and the central measure of tendency will be the arithmetic mean or the geometric mean, and the measure of dispersion may be either the standard deviation or variance or the coefficient of variation. The properties of the scale is summarized in table 12.1, as you can find in page 210 of your textbook. We may also see from the table how the power of the statistic increases as we move away from the nominal scale, where we group subjects or items under some categories, to the ordinal scale, where we order the categories, to the interval scale, where we tap the magnitude or differences, to the ratio scale, which allows us to measure the proportion of the differences. The specific scaling techniques commonly used in business research can be classified into nominal, rating scale, and ranking scale. In nominal and rating scales, each object is scaled independently of the other objects under study. Ranking scale, on the other hand, make comparisons between or among objects and elicit the preferred choices and ranking among them. Specific nominal, rating, and ranking scale are discussed in this topic and also in part 3. First, let's look at nominal scale. There are two types of scale in this category, namely dichotomous scale and category scale. The dichotomous scale is used to elicit a yes or no or two responses from the respondents. The category scale uses multiple items to elicit a single response. The rating scale can further be divided into two scales, ordinal and interval. In ordinal scale, we have two types of scale, namely graphic rating scale and constant sum scale. Under graphic rating scales, a graphical representation helps the respondents to indicate on the scale their answers to a particular question by placing a mark at the appropriate point on the graphic, as in the following example. For constant sum scales, the respondents are here asked to distribute a given number of points across various items as per the example below. This is more in the nature of an ordinal scale. Let's look at the detail of the graphic rating scale, a scale of between 7 through 10 points, and it is normally used for evaluating performance. This is example of Wong-Baker face scale. Patient is asked to choose a face which best describes his or her pain. The number on the face chosen is multiplied by 2 to give a score from 0 to 10. Another example of graphic rating scale is used in the study of word placement on the word graphic rating scale by pediatric patients. These two examples illustrate the use of constant sum scale in their study. Another example of constant sum scale. We have a few scales in interval scale, namely Likert scale, itemized rating scale, stepper scale, semantic differential scale, and numeric scale. The details of each scales will be discussed in our next slides. The Likert scale is designed to examine how strongly subjects agree or disagree with statements on a 5 or 7 or 9 point scale with the following anchors. One strongly disagrees and the other end will be strongly agree. Whether a 7 or 9 point scale fares better than a 5 point scale is debatable. Some researchers say no difference and others say the more choice of responses the better. The responses over a number of items tapping a particular concept or variable can be analyzed item by item, but it is also possible to calculate a total or summated score for each respondent by summing across items. The summated approach is widely used, and therefore the Likert scale is also referred to as the summated scale. A 5 point or 7 point scale with anchors as needed is provided for each item, and the respondent states the appropriate number on the side of each item or circles the relevant number against each item. It is a measure other than level of agreement, for example, satisfaction, importance, likeliness, interest, etc. It is with neutral point, it's balanced rating scale, or without neutral point, unbalanced rating scale. See example on page 215 of textbook. The anchors start from positive to negative or vice versa. Since similar to Likert scale, many researchers claim itemized rating scale as Likert scale. This slide and the next slide illustrates the example of itemized rating scale. Another interval scale is the stepper scale. This scale simultaneously measures both the direction and intensity of the attitude toward the items under study. This gives an idea of how close or distant the individual response to the stimulus is. This is the example of stepper scale on how the respondent described the new mini iPod, whether it is on the negative side or on the positive side. The semantic differential scale possesses several bipolar attributes which are identified at the extremes of the scale, and respondents are asked to indicate their attitudes on what may be called a semantic space toward a particular individual, object, or event on each of the attributes. The bipolar adjectives used might employ such terms as good bad, strong weak, or hot cold. The semantic differential scale is used to assess respondents' attitude toward a particular brand, advertisement, object, or individuals. An example of the semantic differential scale is as follows. The numerical scale is similar to the semantic differential scale, with the difference that numbers on a 5-point or 7-point scale are provided with bipolar adjective at both ends, as illustrated in the next slide. Ranking scales are used to tap preferences between two or among more objects or items. It is ordinal in nature. However, such ranking may not give definite clues to some of the answers sought. Methods used are paired comparisons, first choice, and the comparative scale. The paired comparison scale is used when, among a small number of objects, respondents are asked to choose between two objects at a time. This helps to assess preferences. If, for example, the paired comparisons, respondents consistently show a preference for product 1 over products 2, 3, and 4, the manager can reliably understand which product line demands his utmost attention. However, as the number of objects to be compared increases, so does the number of paired comparisons. The paired comparison is a good method if the number of stimuli presented is small. This is a powerful voting, prioritization, and consensus technique. It is more commonly used by a team, and it is subjective, opinion-based technique. This is an example of paired comparison. In each of the following pairs, which store do you think is better? So the respondent need to choose between Amazon or eBay, between eBay or Yahoo Auction, between Priceline.com and eBay, or between eBay and UB.com. The first choice enables respondents to rank objects relative to one another among the alternatives provided. This is easier for the respondents, particularly if the number of choices to be ranked is limited in number. This is the example of first choice. The respondent needs to choose only one for each of the characteristics. The response of yes, no is another example of first choice. The comparative scale provides a benchmark or a point of reference to assess attitudes toward the current object, event, or situation under study. This is an example of comparative scale using the flag scale, rating scale to be used for children less than 3 years of age or other patients who cannot self-report. This is the example of comparative pain scale. It is important to make sure that the instrument that we develop to measure a particular concept is indeed accurately measuring the variable. In fact, we are actually measuring the concept that we set out to measure. The use of better instruments will ensure more accuracy in results, which in turn will enhance the scientific quality of the research. We need to be reasonably sure that the instruments we use in our research do indeed measure the variables they are supposed to, and that they measure them accurately. Let us now examine how we can ensure that the measures developed are reasonably good. First, an item analysis of the response to the questions tapping the variables is carried out, and then the reliability and validity of the measures are established. We can use these two tests for goodness of measures, reliability and validity. Reliability of measure indicates the extent to which it is without bias or error-free, and hence ensure consistent measurement across time and across the various items in the instrument. The reliability of measure is an indication of the stability and consistency with which the instrument measures the concept and helps to assess the goodness of measure. Validity is the concept. How can we be certain that we are indeed measuring the concept we set out to measure and not something else? This can be determined by applying certain validity tests. The various forms of reliability and validity are displayed in Figure 12.1. We will discuss in detail the item analysis of the responses to questions tapping the variable, and then the reliability and validity of the measures. Item analysis is carried out to see if the items in the instrument belong there or not. In item analysis, the means between the high score group and the low score group are tested to detect significant difference through the t-values. The items with the high t-values, test which is able to identify the highly discriminating items in the instrument, are then included in the instrument. Reliability is a test of how consistently a measuring instrument measures whatever concept it is measuring. We have a few tests in assessing reliability, but we will focus on only test, retest, split half, and Cronbach alpha. The reliability coefficient obtained by repetition of the same measure on a second occasion is called the test-retest reliability. That is, when a questionnaire containing some items that are supposed to measure a concept is administered to a set of respondents, now and again to the same respondents, say several weeks to 6 months later, then the correlation between the scores obtained at the two different times from one and the same set of respondents is called the test-retest coefficient. The higher it is, the better the test-retest reliability and consequently the stability of the measure across time. One concern of test-retest reliability is term carryover effects. Carryover effects benefit individuals from already having taken a test. This enables them to solve problems more quickly or correctly the second time they take the same test. To eliminate carryover effects, researchers often give two highly similar forms of the test to the same person at different times. Split half reliability reflects the correlation between two halves of an instrument. The estimates will vary depending on how the items in the measure are split into two halves. Split half reliabilities may be higher than Cronbach alpha only in the circumstances of there being more than one underlying response dimension tapped by the measure and when certain other conditions are met as well. The inter-item consistency reliability is a test of the consistency of respondents' answer to all the items in a measure. The most popular test of inter-item consistency reliability is Cronbach coefficient alpha, which is used for multi-point scale items. The higher the coefficient, the better the measuring instrument. In almost all cases, Cronbach alpha can be considered a perfectly adequate index of the inter-item consistency reliability. The value ranges from 0 to 1. The widely accepted social sign cutoff is more than or equal 0.7. It is also suggested by Nunnally and Bernstein in 1994, but in some researchers use 0.75 or zero point 0.8. A value as low as 0.6 might be okay for an exploratory study. This is the example of Cronbach alpha. For 6 items, the Cronbach alpha is 0.7, so we can keep all these 6 items. However, Cronbach alpha shouldn't be used as a sole criteria for measuring reliability. It is just a statistical guide for quick decisions on reliability measures. This is the SPSS output for Cronbach alpha. These are the items that we need to look at the Cronbach alpha if item deleted. So let's look at this item. I enjoy my work more than my leisure time. If we delete this item, the Cronbach alpha will improve to 0.743. So we remove these unreliable items and make our tool more reliable. However, Cronbach alpha shouldn't be used as a sole criteria for measuring reliability. It is just a statistical guide for quick decisions or reliability measures. These are the Cronbach alphas for the components. So let's look at component health condition and physical activities and also attitude. The Cronbach alpha with 6 items only 0.583. We need to do something with the number of items, or we have to delete some of the items so that we can improve the Cronbach alpha. And so that's with this attitude component. With these 7 items, the Cronbach alpha is only 0.628. We can improve the Cronbach alpha by deleting some of the items in attitude. Table 12.2 summarizes the kind of validity discussed in the textbook. However, we will only concentrate on the content validity, phrase validity, and construct validity for our lecture. Content validity ensures that the measure includes an adequate and representative set of items that tap the concept. The more the scale items represent the domain or universe of the concept being measured, the greater the content validity. Content validity is a function of how well the dimensions and elements of concept have been delineated. Construct validity testifies to how well the results obtained from the use of the measure fit the theories around which the test is designed. Normally we use factor analysis, a multivariate technique that confirms the dimensions of the concept that have been operationally defined, as well as indicating which of the items are most appropriate for each dimension or establishing construct validity. For phase validity is considered by some basic and minimum index of content validity. Phase validity indicates that the items that are intended to measure a concept do on the face of it look like they measure the concept. Some researchers do not see fit to treat phase validity as a valid component of content validity. In these examples, the more items that can represent the domain of the concept, then the greater the content validity is. In this factor analysis output, the elements are given for factor 1, 2, 3, and 4. For factor 1, 2, and 3, the number of items we provide a Chroma alpha which are more than 0.7. So we can consider factor 1, 2, and 3. But for factor 4, with the number of items 4, the Chroma alpha only 0.586. Therefore, we have to do something with the number of items so that we can improve the Chroma alpha. In summary, the result of a study can only be as good as the measures that tap the concepts in the theoretical framework using validity and reliability measures. Use instruments that are repeatable or more frequently used, especially by the established researchers. Adapt or adopt an established measure to suit the setting, and avoid developing your own instrument unless necessary.